Hi everyone, welcome to this new topic is broadcast containment. In the first point is broadcast domain. When a host receives a message addressed to the broadcast address, it accepts and processes the message as though the message was addressed directly to it. When a host sends a broadcast message, switches forward the message to every connected host within the same local network. For this reason, a local area network, a network with one or more Ethernet switches, is also referred to as a broadcast domain. If too many hosts are connected to the same broadcast domain, broadcast traffic can become excessive. The number of hosts and the amount of network traffic that can be supported on the local network is limited by the capabilities of the switches used to connect them. As the network grows and more hosts are added, network traffic, including broadcast traffic, increases. To improve performance, it's often necessary to divide one local network into multiple networks, or broadcast domain, as shown in the figure. Routers are used to divide the network into multiple broadcast domains. In the image we can see this router uh, who divide these networks: sales broadcast domain, production broadcast domain, and marketing broadcast domain. Okay. The next point is access layer communication. On a local Ethernet network, a NIC only accepts a frame if the destination address is either the broadcast MAC address, media access control, or else corresponds to the MAC address of the NIC. Most network applications, however, rely on the logical destination IP address to identify the local of the server and clients. The figure illustrates the problem that arises if a sending host only has the logical IP address of the destination host. How does the sending host determine what destination MAC address to place within the frame? The sending host can use the IPv4 protocol called Address Resolution Protocol (ARP) to discover the MAC address of any host on the same local network. IPv6 uses a similar method known as a neighbor discover (ND). Okay, and in the image we can see I need to send information to this address, but I only have the IPv4 address. I don't know which device has that IPv4 address, say H1. Okay. The next point or topic is ARP. ARP uses a three-step process to discover and store the MAC address of a host on the local network when only the IPv4 address of the host is known. The first step is the sending host creates and sends a frame addressed to a broadcast MAC address. Contained in the frame is a message with the IPv4 address of the intended destination host. The step 2, each host on the network receives the broadcast frame and compare the IPv4 address inside the message with its configured IPv4 address. The host which the matching IPv4 address sends its MAC address back to the original sending host. And the last step is 3. The sending host receives the message and stores the MAC address and IPv4 address information in a table called an ARP address resolution protocol. When the sending host has the MAC address of the destination host in its ARP table, it can send frames directly to the destination without doing an ARP request, because ARP's message really on broadcast frames to deliver the request. A host in the local IPv4 network must be in the same broadcast domain. And okay, I must send out an ARP request to learn the MAC address of the host with the IP address. Okay. Now I have the MAC address. I can forward my information. Once again, this isn't me, this is me, and send the message or packet with the necessary information. Okay. And finish with check your understanding in broadcast containment. The first question is the destination MAC address of an Ethernet broadcast in hexadecimal is 48 bits. The destination MAC address for an Ethernet broadcast. Okay, reset. Okay, that's right. The destination MAC address for an Ethernet broadcast is in this form. Question 2. When an Ethernet switch receives a frame that is broadcast, it will. Okay, when an Ethernet switch receives a frame that is broadcast, it will forward the frame out only ports that need broadcast, forward the frame out all ports including the incoming port, forward the frame out all ports except the incoming port. Submit. That's right. When an Ethernet switch receives a frame that is broadcast, it will forward the frame out all ports except the incoming port. And question 3. Host A has an Ethernet frame to send to host B on the same network. Host A knows the IP address of host B, but not its MAC address. What message will host A send to the terminal to determine the MAC address of host B is ARP request or ARP broadcast. Request ARP broadcast request. That's right. A host will send an ARP address resolution protocol request to determine or determine the MAC address of another devices. And question 4. An ARP request is sent out as a unicast, so only the device with the proper MAC address will receive it. A broadcast, so all devices on the network and other networks no. A broadcast, so all devices on the same network will receive it. An ARP request is broadcast, so all devices on the network will receive it. Question 5. Host B receives an ARP request. Host B will return an ARP reply if the IP and MAC address in the ARP request match its own IP and MAC address. The MAC address in the ARP request match its own MAC address. The ARP address in the ARP request match in their own. That's right. A host will send an ARP address resolution protocol reply if the IP address in the ARP request match its own IP address. Question 6. Host A sent an ARP request and received an ARP reply from host B. What is in the ARP reply that host A did not know and needs to communicate with host B? Host B is IP address, host B, IP address, and MAC address. An ARP reply will include the IP and MAC address of the host that sent the reply. Okay, host B. Okay. And finish with the ARP Process Summary. What did I learn in this module? MAC and IP. Sometimes a host must send a message, but it only knows the IP address of the destination device. The host needs to know the MAC address of that device. The MAC address can be discovered using address resolution. There are two primary addresses assigned to device on an Ethernet LAN. The first is physical address, the MAC address, media access control, used for NIC-to-NIC communication on the same Ethernet network. The next is logical address, the IP address, used to send the packet from the source device to the destination device. The destination IP address may be on the same IP network as the source, or it may be on a remote network. When the destination IP address IPv4 or IPv6 is on a remote network, the destination MAC address will be the address of the host default gateway, the router interface. Router examines the destination IPv4 address to determine the best path to forward the IPv4 packet. When the router receives the Ethernet frame, it encapsulates the layer 2 information using the destination IPv4 address. It determines the next hub device and then encapsulates the IPv4 packet in a new data link frame for the outgoing interface. Along each link in a path, an IP packet is encapsulated in a frame. The frame is specific to the data link technology that is associated with the link, such as Ethernet. If the next hub device is the final destination, the destination MAC address will be that of the device Ethernet NIC. And the next tab is Broadcast Containment. A message can only contain one destination MAC address. Address resolution lets a host send a broadcast message to a unique MAC address that is recognized by a host. The broadcast MAC address is a 48-bit address made for all ones. MAC addresses are usually represented in hexadecimal notation. The broadcast MAC address is hexadecimal notation is in this form. HF in the hexadecimal notation represents 4 ones in the binary address. When a host sends a broadcast message, switch forward the message to every connected host within the same local network. For this reason, a local area network, a network with one or more Ethernet switches, is also referred to as a broadcast domain. If too many hosts are connected to the same broadcast domain, the broadcast traffic can become excessive. The number of hosts and the amount of network traffic can be supported on the local network is limited by the capabilities of the switch used to connect them. To improve performance, you may need to divide one local network into multiple networks, or broadcast domain. Routers are used to divide the networks into multiple broadcast domains. On a local Ethernet network, a NIC only accepts a frame if the destination address is either the broadcast MAC address or else corresponds to the MAC address of the NIC. Most network applications rely on the logical destination IP address to identify the location of the servers and clients. How does the sending host determine what destination MAC address to place within the frame? The sending host can ARP address resolution protocol to discover the MAC address of any host on the same local network. ARP uses a three-step process to discover and store the MAC address of a host on the local network when only the IPv4 address of the host is known. The first step is step 1. The sending host creates and sends a frame address to a broadcast MAC address. Contained in the frame is a message with the IPv4 address of the intended destination host. Each host on the network receives the broadcast frame and compares the IPv4 address inside the message with configured IPv4 address. The host with the matching IPv4 address sends its MAC address back to the original sending host. And the last step is the sending host receives the message and stores the MAC address and IPv4 address information in a table called an ARP table. IPv6 uses a similar method known as neighbor discovery. Webster reflection question. All of my devices and all of your devices have an IP address and a MAC address. When someone wants to send a message to my phone, my IP address tells the router where my device is. My MAC address is how my phone knows to let me see the message. The router also needs to know my MAC address and I use ARP to find it. Do you know how to look up the MAC address of each of your connected devices? Finish with the Address Resolution Process Quiz. Question 1. What is one function of the ARP protocol? Obtain an IPv4 address automatically? No. Mapping a domain name? No. Resolving an IPv4 address to a MAC address? Maintain a table of domain names with their resolved IPv4 address? Resolving an IPv4 address to a MAC address? Maintaining a table of domain names with their resolved IP address. Okay, I need to translate this. Okay. Question 2. Which destination address is used in an ARP request frame? Which destination address is used in an ARP request frame? Okay, is this. And question 3. Which statement describes the treatment of ARP requests on the local link? They must be forwarded by all routers on the local network. They are received and processed by every device on the local network. They are dropped by all switches on the local network. They are received or processed only by the target device. They must be forwarded by all routers on the local node. They are received and processed by every device on the local network. Okay. Yes. Question 4. What important information is examined in the Ethernet frame header by the layer 2 device in order to forward the data onward? Source MAC address, no destination MAC address. What important information is examined in the Ethernet frame header by a layer 2 device in order to forward the data onward? Destination MAC address. Question 5. What are two functions of MAC address in a LAN? To allow the transfer of frames from source to destination. To determine which host has priority to transfer data. To indicate the best path between separate networks. To associate with a specific network IP address. To uniquely identify a node on a network. To indicate the best path between separate networks. Okay, question 6. Refer to the exhibit. PC1 issues an ARP request because it needs to send a packet to PC2. In this scenario, what will happen? What will happen next? Okay, PC1 needs to send a packet to PC2. Okay, PC2 will send an ARP reply. No. Router 1 will send an ARP reply. No. Router 1 will send an ARP reply. No. Switch 1 will send an ARP reply. with the PC to MAC address. Switch 1 will send an ARP reply with the switch 1. No. Switch 1 will send. Okay. Yes. And question 7. What address are mapped by ARP? IP address to destination MAC address. Okay. Destination IPv4 address to the source. Destination IPv4 address to the destination host name. Destination MAC address to the source. Question A. Refer to the exhibit. Switches Switch 1 and Switch 2 have MAC address tables that are populated with all the exhibit host MAC addresses. If host 1 H1 sends a frame with destination address, what will be the result? Okay. Switch 1 discard the frame. Switch 1 will flood the frame out of ports except the inbound port. The frame will be discarded. Okay. Question 9. Refer to the exhibit. Host A needs to send a data to the server, but does not know its MAC address. When host sends out an ARP request, what response will be in the ARP reply? Okay. And question 10. Open the PT activity, perform the task in the activity instruction, and then answer the question. When PC0 pings the web server, which MAC address is the source MAC address in the frame from R2 router 2 to the web server? Question 11. What statement describes a characteristic of MAC address? Okay. Which two characteristics describe MAC address? And go wait a second. Review the device in the network. Use the Inspect tool, the magnifying glass icon, and display the port status summary table for the device. When PC0 ping the web server, PC0 pings the web server, which MAC address is the source MAC address in the frame from router 2 to the web server. Return the assessment to complete the task. Okay. Configure is locked by authors. Simulation. Okay. And display the port status summary table for devices. When PC0 pings the web server, which MAC address is the source MAC address? When PC0 pings When PC0 pings the web server, which MAC address is the source MAC address in the frame from router 2 to the web server? Okay. Oof. Okay. Once again. Okay, congratulations, you have passed the test. Okay, this is all for this. See you in the next one. Bye.